This problem is tricky because we're combining shapes for our bases that we're not used to combining. We've often seen a rectangular prism, which would just have a rectangle as a base, or a triangular prism, which would just have a triangle as a base, or a cylinder, which has circles as bases, but we haven't done a lot of combining different shapes to make our base. But remember what the base of a prism is. The base are congruent sides, which are opposite of each other, and they're parallel, so they're connected by lines from all of the points of that base. So in this prism right here, we want to decide which two sides are our bases. So let's say you were to guess the triangle. Well, yes, the two triangles are congruent shapes that are opposite from each other, and they're parallel, connected by these three lines. But that wouldn't include the bottom half of the shape. Same if we chose the rectangle. If we chose this rectangle as our base, then we would have congruent rectangles that are opposite and connected by these four lines, but that would disregard this triangle. So in actuality, in this case, we're going to include this rectangle and this triangle. So if we look at that whole little house-like shape as our base, you'll notice that those are congruent. There's a house-like shape here and a house-like shape here, and they're congruent, they're opposite, they're connected by all these lines. So I like to think of bases as if you had a shape and another congruent shape right on top of each other, and then you simply extend them outward. That creates the height of the prism and all these lines connecting the vertices of that original base. So we've now decided that the base of this shape is this house-like figure, which is the rectangle and the triangle. So when you're finding the area of the two bases together, you need to find the area of the rectangle and the triangle together and then times by 2 to get the other side. But the lateral surface area can be a little tricky as well. For lateral surface area, remember, those are all the faces which are not a part of the base. So in this case, it's all these rectangles which connect the two bases but are not included in the base. So how many sides are included in the lateral surfaces? Well, here it's actually 5. We have the right side of this rectangle here, the left side here, the bottom, and then the two sides created by these triangles up here. So there are two ways you can go about finding the lateral surface area. One, you can simply find the area of all those rectangles and add them together. That's a totally valid way to do it. However, the second way is how we've started doing it in this unit, which is where we find the perimeter of the base and we times by the height. When in reality, that's simply doing the same thing, because if you were going to find, let's say, the area of this rectangle, the right side of this triangle, by the height, you would take this side length of the triangle times the height. And for this rectangle, you would take this side of the base and times by the height. For the bottom, you would take this side of the base and times by the height, and same for the other two sides of the lateral surfaces. But that is simply the perimeter of the base times by the height. That will find all 5 areas of the lateral sides for you. So I think that's a good method to find the perimeter of the base, which would be the 3 sides of this rectangle and the 2 sides of this triangle times the height. Now, you wouldn't include the bottom of this triangle because that does not form that is not an edge of one of the lateral surfaces, because we've included the triangle and the rectangle together. See if that helps you find the bases or the lateral surface areas and then the volume. And if you're still confused, send myself or Mr. Geiselhart an email and we can help you more.